d square s by dt square is called the acceleration of the particle. So rate of change of area is dA by d into with respect to radius means dr. This is required to be determined. What is the rate of increase of the circumference? And the surface area of the cube A is equal to 6x square. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in the previous classes, we have discussed regarding the different types of differentiations and the mean value theorems. In this session, I am going to discuss regarding the application of derivatives. So, in application of derivatives, we are going to study only few concepts, that is rate measure. The first concept we are going to study is the rate measure, then equation of tangent and normal, finding the slope, then finding the equation tangent of a curve, equation of tangent and normal, then the increasing and decreasing function, then we are going to study regarding approximation, finding the approximate value using differentiations, and finally maxima and minima. These are the 5 concepts we are going to study in application of derivative. That is, first one is the rate measure, second one is equation of tangent and normal by finding the slope, then the third concept we are going to study is increasing and decreasing function, then the fourth concept is finding the approximate value using differential, and the last concept is maxima and minimum of a function. In all these 5 concepts, the weightage marks is 10 marks, 1 2-mark question. You will get 1 2-mark question and 1 3-mark question and 1 5 compulsory question. 5-mark question is from this rate measure. Definitely you will get either from rate measure or from maxima and minima of a function. So the total weightage for this application of derivatives, the chapter application of derivatives, is 2 marks 1 question, 3 marks 1 question and 5 marks 1 question, totally 10 marks. Now let me discuss the first concept, rate measure. Now, rate measure, rate, actually d by dt represents the rate of change of displacement or rate of change of velocity that you might have been studied in your physics classes. The same concept we are going to study in mathematics also. That is, suppose here the d by dt represents the rate of change of what? With respect to time. Now suppose if s is a displacement or distance traveled, if s is the distance traveled or displacement of a particle in time t seconds, then the rate of change of displacement is denoted as ds by dt. ds by dt is called the velocity. The rate of change of displacement is denoted as ds by dt. That is called velocity. So the rate of change of displacement ds by dt is called the velocity of a particle. That means if you differentiate a function, first derivative will give the rate of change, that is velocity. Now suppose if you differentiate this function again, differentiating ds by dt with respect to t, differentiating with respect to t, d by dt of ds by dt can be written as d square s by dt square. d square s by dt square is denoted as acceleration A. Therefore, d square s by dt square is called the acceleration of the particle and it is denoted as A. Or you can also write the rate of change of velocity dv by dt is called the acceleration. So, if you differentiate the given function 1 time, you will get the velocity. If you differentiate 2 times, you will get the acceleration. Thus, the rate of change of displacement ds by dt is called the velocity, and the rate of change of velocity is called the acceleration, that is d square s by dt square. Now, suppose if the velocity is equal to 0, if ds by dt is equal to 0, what do you say? The velocity is said to be 0 means the particle is said to be under rest. If the velocity is 0 means the particle is under rest. Suppose if the acceleration is 0 means acceleration 0 in the sense the rate of change of velocity. That means the particle is moving under uniform velocity. So these are the concepts, very important concepts. So in general, if you differentiate 1 time, you will get the velocity. If you differentiate 2 times the second derivative of a function will give the acceleration of the particle at time t seconds. Now let us take a problem. For example, let us consider if s is the displacement of a particle given by s is equal to t cube plus 4t plus 1. Find the velocity and acceleration at the end of 1 second. Suppose if you want to find the velocity and acceleration at the end of 1 second, differentiate this with respect to t. ds by dt is equal to differentiation of t cube is 3t square plus 4 into differentiation of t is 4. If you put t is equal to 1, what you will get? Velocity is equal to 3 into 1 plus 4, that is equal to 7. Velocity is equal to 7. So here the unit, suppose if it is in terms of meters per second or centimeters per second, velocity is equal to 7 meters per second. Suppose if you differentiate this again, d by dt of ds by dt, that is equal to d by dt of, what is ds by dt here? So 3t square plus 4, d square s by dt square is equal to 3 2s are 6t. Substitute the value of t is equal to 1, what you will get? The acceleration is equal to 6 into 1, that's equal to 6 meter per second square. Now, therefore, acceleration is equal to 6 meter per second square. And the velocity is equal to 7 meters per second. So this is the method we are used to find the velocity and the acceleration. This is how we are going to find the velocity and acceleration of a particle. Now let us come to the problem, the exact problems in this rate measure. So in general, d by dt represents the rate of change. Rate of change of radius means ds by dr by dt. Rate of change of area means dA by dt. Rate of change of volume means dV by dt. These are the few concepts which we are going to study in this type of problems. Rate of change of displacement, rate of change of velocity, rate of change of radius, rate of change of area, and rate of change of volume. Okay. Now let us take a problem. Now let us take one simple problem. When brakes are applied to a moving car, the car travels a distance of s feet in t seconds is given by s is equal to 8t minus 6t square. When does the car stops? How far does it move before coming to rest? Also find the acceleration of the car. Now, what is the equation given? S is equal to 8t minus 6t square. Okay. Now that is, when brakes are applied to a moving car, the car travels a distance of s feet in time t seconds is given by s is equal to, the distance traveled is given by 8t minus 6t square. When does the car stops? First, then how far does it move before coming to the rest? Also find the acceleration. Now let us differentiate this. Differentiating with respect to time t. ds by dt is equal to differentiation of 8 into t is 1 minus 6 into t square is 2t. This is 8 minus 12t. Now on the other hand, differentiate again with respect to t. We are differentiating with respect to t. d square s by dt square is equal to 8 constant 0 minus 12 into derivative of t is 1. This is equal to minus 12. So first derivative is 8 minus 12t and the second derivative is minus 12. Okay. Now here the first derivative is 8 minus 12t. What is this? ds by dt is called the velocity. Velocity is equal to 8 minus 12t. Velocity is 8 minus 12t. Now acceleration is nothing but find the acceleration. D square s by dt square itself is nothing but the acceleration. Acceleration is equal to minus 12. Negative acceleration. Now what is to find is the acceleration is found to be minus 12. Second derivative will give the acceleration. When does the car stops? So when does the car stops? How far does it move before coming to the rest? Now here, when does it stop means when the velocity is equal to 0. Equate velocity to 0. If velocity is equal to 0, it will comes to the rest. The particle is said to be under rest if velocity is equal to 0. So velocity is equal to 0 in the sense this s minus 12t is equal to 0. This implies 8 minus 12t is equal to 0 implies 8 is equal to 12t, or t is equal to 8 divided by 12. Divide from 4. 4 2s are 4 3s are 4 2s are and 4 3s are. So t is equal to 2 by 3. T is equal to 2 by 3. So when time t is equal to 2 by 3 seconds, the car stops. After applying the brakes, it will stop. It will come to the rest after 2 by 3 seconds. Now to find how far does it move before coming to the rest. Now substitute the value of t is equal to 2 by 3 in this given equation. You will get the value of s. Substitute here. Substituting the value of s. Put s is equal to, now put here. I'll rub this. Now put t is equal to 2 by 3 in equation number 1. S is equal to 8 into 2 by 3 minus 6 into 2 by 3 whole square. This is 8 2s are 16 by 3 minus 6 into 2 2s are 4 divided by 9, or you can also divide from 3 to, yes, 3 3s are 3 2s are 6. This is nothing but take LCM. 3 is the LCM. 16 minus 2 4s are 8. So 16 minus 8 is 8. 8 by 3. The distance traveled is 8 by 3 feet, and the velocity is nothing but velocity is equal to 0. If you equate velocity equal to 0, then you will get the time t is equal to 2 by 3 seconds. Now this is how we are going to solve this problem. Now next come to the next type of problem. In the next type of problem, we are going to discuss regarding the problems based on circles, rectangle and the cones. Now let us discuss the problems based on the circles, problems related to circles, problems based on circle. Now suppose if r is the radius of a circle, then the area of a circle is given by area is equal to pi r square. You know the area of a circle is given by pi r square. The circumference of the circle is given by 2 pi r. Area is equal to pi r square and the circumference of a circle is 2 pi r. So here r is the radius of a circle. Now let us consider a problem. Before that, suppose if the rate of change of area with respect to time is dA by dt. Rate of change of area with respect to radius r means dA by dr. So just keep in mind. Now here the problem, let us consider a small example. What is the problem given? Find the rate of change of area of a circle with respect to radius r. See here, rate of change of area of a circle with respect to radius. So rate of change of area is dA by d into with respect to radius means dr. This is required to be determined. dA by dr. And what is given? R is also given. There are two conditions. One, r is equal to 3 centimeters. Another problem, r is equal to 4 centimeters. Two problems are there. Now we know that what is the area? Area of a circle is pi r square. Now differentiating with respect to r, the radius, because the rate of change of area of a circle with respect to radius is to be determined. So therefore differentiate with respect to r. dA by dr is equal to pi constant. Differentiation of r square is 2r. That's it. dA by dr is equal to pi into 2r. Now just substitute the value. Now let me take a, first one, a. When r is equal to, just when r is equal to 3 centimeters, this becomes dA by dr is equal to pi into 2 into r is 3. So this is equal to 3 to the 6 pi. Therefore the required area is equal to 6 pi, since it is an area, 6 pi centimeter square per centimeter. Centimeter square per centimeter. Similarly, substitute the value of r is equal to 4 centimeters. For the second case, when r is equal to 4 centimeters, what we will get? dA by dr is equal to pi into 2 into 4. This is equal to 8 pi, same, centimeter square per centimeter. So therefore, the rate of change of area with respect to radius for the problem given is, one is 6 pi, another one is 8 pi. For 3 centimeters it is 6 pi, for 4 centimeters it is 8 pi. This is the required solution for this problem. Now let us come to the next problem. Go to the problem. What is the problem? The radius of a circle, the radius r of a circle is increasing uniformly at the rate of 3 centimeters per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeters. Similar type problem. Here the statement is given. The radius of a circle is increasing at the rate of 3 centimeters per second. Suppose let r is the radius. Solution I will write. Let r be the radius of the circle. If r is the radius of the circle, then what is given? The radius is increasing. Dr by dt is equal to, given dr by dt is equal to 3 centimeters per second. Suppose let r is the radius of the circle, then given dr by dt, dr divided by dt, dr by dt is equal to 3 centimeters per second. Find the rate at which the area of a circle is increasing. What is required to find is dA by dt is equal to question mark. Rate. Find the rate at which the area of the circle is increasing when the radius is 10 centimeters. R is equal to 10 centimeters. This is given. Okay, since we know that what is the area of a circle? Area is equal to pi r square. Since dr by dt is given, differentiate with respect to t. Differentiating with respect to t. This is dA by dt is equal to pi into differentiation of r square is 2r. Since we are differentiating r with respect to t, this can be written as dr by dt. Substitute the values. dA by dt is equal to pi into 2 into what is r? R is equal to 10 centimeters into what is dr by dt? dr by dt is equal to 3 centimeters per second. Multiply this. What you will get? 3 into 2 is 6. 6 tens are 60 pi. So dA by dt is equal to 60 pi centimeters area centimeter square per second. So the required area is equal to 60 pi centimeters square per second. So the required area is equal to dA by dt is equal to 60 times pi centimeters square per second. That's it. Now let us come to the next problem. What is our next problem? The radius of a circle is increasing at the rate of 0.7 centimeters per second. What is the rate of increase of the circumference? Now again here the circumference problem is given. Suppose if r is the radius, r is the radius, radius of a circle, c is the circumference. The circumference of the circle is given by c is equal to 2 pi r. The circumference of the circle. Now radius of a circle is increasing at the rate of 0.7 centimeters per second. What is the rate of increase? So here given dr by dt is equal to 0.7 centimeters per second. Differentiate this. Differentiating with respect to t. What you will get? d into c. dc divided by dt is equal to 2 pi constant. We are differentiating r with respect to t. Therefore, this can be written as dr into dr by dt. This is 2 pi into, substitute the value of dr by dt 0.7. This is equal to 0.7 into 2 is 1.4. 1.4 times pi. And what is the unit here? Since this is the circumference, centimeter square per second. The required answer is 1.4 pi. So the required answer is equal to 1.4 pi centimeters per second. The circumference. I will explain once again. The radius of a circle is increasing. The radius of a circle is increasing at the rate of 0.7 centimeters per second. That means dr by, suppose if r is the radius of a circle, then dr by dt is equal to 0.7 centimeters per second. That is given. What is the rate of increase of the circumference? So the circumference of the circle is given by c is equal to 2 pi r. The circumference of a circle, c is equal to 2 pi r. This is the formula. C is equal to 2 pi r. Differentiating with respect to t, d into c, dc divided by dt is equal to, dc by dt is equal to 2 pi into derivative of is dr by dt, because we are differentiating r with respect to t. 2 pi into, substitute the value of dr by dt 0.7. 2 pi into 0.7 can be written as 1.4 pi. So the required circumference the rate of increase of the circumference dc by dt is given by dc divided by dt is equal to 1.4 centimeters per second. This is the required solution. Now let us come to the next problem. This is again very important problem. These are all very important problems for 3 marker questions. A stone is dropped into a quiet lake. A stone is dropped into a quiet lake and waves moves in circle at the speed of 5 centimeters per second. Suppose this is a lake. If stone is dropped, the waves will move like this. The waves will form a circle. Circular waves are formed at a speed of 5 centimeters per second. At the instant when the radius of the circular wave is 8 centimeter. Suppose if the radius of the circular is 8 centimeter, then how fast is the enclosed area increases? Now you have to find out the area enclosed. How fast is the enclosed area increases? Very important and very easy problem. Now what is the problem is given? A stone is dropped into a quiet lake and waves moves in circles at the speed of 5 centimeters per second. At the instant when the radius of the circular wave is 8 centimeters, how fast is the enclosed area increases? First of all, this is a circle. Therefore, if r is the radius, then the area of a circle is equal to pi r square. Here, the time is given at the speed of 5 centimeters per second. Differentiate with respect to t. dA by dt is equal to pi into differentiation of r square is 2r into, we are differentiating with respect to t, differentiating with respect to t, this is dr by dt. Now substitute what is given, substitute. Now let us write what is given. A stone is dropped into a quiet lake, the waves moves in a circle at the speed of 5 centimeters, the rate of change. So here what is given, dr by dt is equal to 5 centimeters per second. And at the instant when the radius of the circle wave is 8 centimeter, r is equal to 8 centimeters. What is required to find is dA by dt at this instant. That's all. See here. So if A is the area, if r is the radius and A is the area of a circle is given by pi r square, differentiating with respect to t, dA by dt is equal to pi into 2r dr by dt. Given that dr by dt is equal to 5 centimeter and r is equal to 8 centimeters, substitute here pi into 2 into what is r? R is 8 centimeters and dr by dt is equal to 5 centimeters. Now multiply this, 5 2s are 10 into 8 is 80 pi. This is dA by dt. Since it is rate of change of area, area is represented by the unit centimeter square per second. Centimeter square per second. This is the required area. So dA by dt is equal to 80 times pi, 80 pi centimeter square per second is the required answer. Next, let us come to the next problem. Same. A circular disc of radius 3 centimeters is being heated. Due to expansion, its radius increases at the rate of 0.05 centimeters per second. Find the rate at which the area is increasing when the radius is equal to 3.2 centimeters. This is also a very simple problem. Here a circular disc, again a circle is given, the radius is 3 centimeters, radius of a circular disc is 3 centimeters, radius is given, being heated due to expansion, the radius is increasing at the rate of change of radius is given 0.05 centimeters. Find the rate at which the area is increasing when its radius is equal to 3.2 centimeters. What is the given condition given? A circular disc of radius 3 centimeters, whatever it may be, is heated. Due to expansion, the radius is increasing. Given if r is the radius, the increase in rate of change of radius is given by 0.05 centimeters per second. Find the rate at which the area is increasing when the radius is equal to 3.2 centimeters. 3.2 centimeters. What is required to find is dA by dt. This is required answer. Now, you know what is the area of a circle? Area is equal to pi r square. Differentiating with respect to t. If you differentiate with respect to t, what you will get? dA by dt is equal to pi into Differentiation of r square is 2r into dr by dt. Substitute the values. dA by dt is equal to pi into 2 into, what is r? R is equal to 3.2 into dr by dt. dr by dt is equal to 0.05. So this is nothing but, multiply this, pi into 3.2 into 2 is nothing but 6.4. 6.4 into 0.05. This is equal to, simplify this. Now after simplification, this is equal to 0.320, 0.320 pi. This is the area, centimeter square per second. That's it. This is the required. So what is the required area? 0.320 pi centimeter square per second. See here, A is equal to pi r square, differentiating with respect to t, dA by dt is equal to pi into, derivative of r square is 2r into dr by dt, pi into 2 into r is 3.2 and dr by dt, the rate of change of radius is given, small change is 0.05, 3.2 into 2 is 6.4 into 0.05 is nothing but 0.320 pi centimeter square per second is the required increase in the area when the radius is equal to 3.2 centimeters. Followed? Now let us come to the next problem. Let us take few problems based on the cube. Suppose if x is an edge of a cube, then the volume of a cube is given by volume V is equal to x cube, and the surface area of a cube is given by 6x square. These are two important formulas. So the volume V is equal, volume of a cube is x cube, and the surface area of a cube is A is equal to 6x square. Let us consider this problem. Now what is the problem given? The volume of a cube is increasing at the rate of 8 cm cube per second. Volume of a cube is increasing, that is dV by dt is 8 centimeter cube per second. This is given. How fast is the surface area is increasing? Surface area is nothing but dA by dt. How fast is the surface area increasing? When the length of an each edge is equal to 12 centimeters. This is the question. So what is given? dV by dt is equal to 8 centimeter cube per second. What is required to find is dA by dt when x is equal to 12 centimeters. Now let us use the volume first. Volume of the cube is given by V is equal to x cube, differentiating with respect to t, because it is dV by dt is given. dV by dt is equal to, again function of a function, differentiation of x cube is 3x square into dx by dt. Now what is given? dV by dt is given 8 is equal to 3x square into dx by dt. Therefore dx by dt can be written as 8 divided by 3x square. 8 divided by 3x square. Let us represent this as equation number 1. What is the volume? What volume is nothing but 8 centimeter cube. So 8 is equal to 3x square into dx by dt. Therefore dx by dt alone is equal to 8 divided by 3x square. Again further, what is given? How fast is the surface area increasing when the length of an edge is equal to 12 centimeter? Surface area is increasing. What is the formula for surface area? A is equal to 6x square. Now let us use this formula. Now first what we got? dx by dt. I will rub this and I will do here. I will rub this. Now what is the surface area? S is equal to, yes, surface area 6s square, 6x square. Now differentiating with respect to t, what you will get? ds by dt is equal to 6 into differentiation of x square is 2x into dx by dt. Now substitute the value 6 into 2 into x. What is x? X is equal to 12 centimeters into dx by dt is nothing but 8 divided by 3 times x square. So 12 and 12 gets cancelled. What you will get here? 6 into 2 is 12 into 8 divided by 3 into 12. Again 12 gets cancelled. This is equal to 8 by 3. 8 by 3 is the required answer for this problem. So what is the required answer? 8 by 3. What is the unit? Since it is an yes. What is this? ds by dt, surface area. So we are going to get centimeter square per second is the required area. So the required area for this is 8 by 3 centimeter square per second. So first use volume x cube and find out the value of dx by dt, and use surface area is equal to 6x square, differentiate and substitute the value of dx by dt and the value of x. You will get ds by dt is equal to 8 by 3 centimeter square per second, which is the required answer. Now let us come to the next problem. Now what is the next problem? An edge of a variable cube is increasing at the rate of 3 centimeters per second. How fast is the volume of a cube is increasing when the edge is 10 centimeters? How fast the volume of a cube? Volume of a cube. What is the formula? Suppose let x is an edge of the cube, then the volume is given by, what is the formula for volume? V is equal to x cube. What is given? An edge of a variable cube is increasing, that is dx by dt is equal to 3 centimeters per second. How fast is the volume of the cube increases when each edge is equal to 10 centimeter, when x is equal to 10 centimeters. Here, the edge of a variable cube is increasing at the rate of 3 centimeters per second. How fast is the volume of a cube increases when the edge is 10 centimeter long? Let us consider, let x be an edge of the cube. So what is given? Dx by dt is equal to 3 centimeters per second. And what is required to find? dv by dt when x is equal to dv by dt when x is equal to 10 centimeters. Since you know the volume of a cube is given by volume of the cube v is equal to x cube, then differentiate with respect to t. Differentiating with respect to t, what you will get? dv by dt is equal to 3x square into dx by dt. 3 into, substitute the value of x, x is equal to 10 square into dx by dt is equal to 3 centimeters. So this is 3 into 3 is 9 into 100, that's equal to 900. It is a volume. This is dv by dt volume. The rate of change of volume is nothing but cubic centimeters per second. Cubic centimeters per second, cc. Now here 3x square into dx by dt, 3 into x value is equal to 10 centimeter, dx by dt is equal to this. So multiply this 3 and 10 into 10, 100 into 9. This is nothing but 900. So dv by dt, the rate of change, the rate, how fast is the volume increasing means the rate of change of volume. Since it is a volume, therefore the unit is dv by dt is equal to 900 centimeter cube per second. The unit is 900 centimeter cube per second is the required answer for this. Now listen to me once again, I will explain. So the volume is x cube, given dx by dt is equal to 3 centimeters, and it is required to find dv by dt when x is equal to 10 centimeter. Volume is equal to x cube, differentiating with respect to t. dv by dt is equal to differentiation of x cube is 3x square dx by dt. Substitute the values of dx by dt and x. X is 10 square, dx by dt is 3. 3 3s are 9 into 10 square is 100, that is 900 centimeter cube per second is the required volume. Now let us come to the next problem. Now this is very important problem. This is for 5 marks. This is a 5-marker question. Usually you will get this type of question for 5 marks. The length x of a rectangle is decreasing at the rate of 5 centimeters per minute, and the width y is increasing at the rate of 4 centimeters per minute. When x is equal to 8 centimeters and y is equal to 6 centimeters, find the rate of change of, what is that? Perimeter and the area of a rectangle. Perimeter of a rectangle and the area of a rectangle. This is very important. Now, first, let us write down what is given. Given the length x of a rectangle is decreasing at the rate dx by dt. If x is the length and y is the breadth, given dx by dt is equal to 5 centimeters per minute, given that dx by dt is equal to 5 centimeters along with negative sign. The length x of a rectangle is decreasing at the rate of 5 centimeters means dx by dt is equal to minus 5 centimeters. The negative sign indicates it is decreasing. Further, the width y, suppose if y is the width, the rate of change of width y is increasing at the rate of 4 centimeters per minute. This is positive because this is increasing. Dx by dt is negative, dy by dt is positive. What is required to find? To find the perimeter. If P is the perimeter, dP by dt. And the area of the rectangle, if A is the area, then dA by dt. This is to be required to be found. This is required to be determined when x is equal to 8 centimeters and y is equal to 6 centimeters. This is the problem. Okay, very simple problem. First, write down the given condition. What is the given condition? The length x of a rectangle is decreasing at the rate of 5 centimeters per minute, means dx by dt is equal to minus 5 centimeters per minute. And the width y increasing at the rate of 4 centimeters per minute, means dy by dt is equal to 4 centimeters per minute. What is required to find is area. The perimeter, the rate of change of perimeter is dp by dt. And rate of change of area of a rectangle is dA by dt when condition x is equal to 8 and y is equal to 6. Okay. Now let us come to the first one, the perimeter. What is the formula for perimeter? Perimeter is equal to sum of all the sides, 2x plus 2y. And what is the area of a rectangle? Area is equal to length into breadth, that is nothing but x into y. What is given from the previous page? So what is given? Dx by dt is equal to minus 5 centimeters per minute. Dy by dt is equal to 4 centimeters per minute. Now let us take the perimeter. First one, perimeter. P is equal to 2 times x plus y. 2x plus 2y. That is nothing but 2x plus 2y. If I remove 2 common factor, 2 times x plus y. Now differentiating with respect to t. What you will get? dp by dt is equal to 2 into differentiation of this is dx by dt plus dy by dt. What is given? Since given that dx by dt is equal to minus 5 centimeters per minute and dy by dt is equal to 4 centimeters per minute. Substitute here. dp by dt is equal to the perimeter minus 5 plus 4. This is equal to 2 into minus 1. This is equal to minus 2. Therefore, the perimeter dp by dt is equal to 2 centimeters per minute. So, the negative sign indicates it is decreasing. The perimeter is decreasing. Okay. This is the answer for the perimeter. Let us come to the next part. What is required to find is the next part is the area. Let us come to the second one is the area of a rectangle. Now come to the area. Area of a rectangle. Area is equal to x into y. Differentiate this dA by dt. This is the second one. dA by dt is equal to, this is product rule, first function dy by dt plus y into dx by dt. Substitute the values. What is x? You know what is the value of x? X is equal to, when x is equal to 8, x is equal to 8 and y is equal to 6. Substitute here. 8 into dy by dt. dy by dt is 4 plus y is 6 into dx by dt is equal to minus 5. So what is this equal to? This is 8 into 4. Now multiply this. This is 8 into 4. 32 minus 5 into 6 is 30. This is equal to 2. So therefore, dA by dt is equal to 2. The surface area, rate of change of area is given by 2 centimeters square per minute. That's all. So the area, the rate of change of area is given by 2 centimeters square per minute is the required area for this problem. Now let us come to the same type problem. One more problem, similar problem. Let me take one more problem. Same type. The length x of a rectangle is decreasing at the rate of 3 centimeters per minute. Straight away I will write what is given. Given that dx by dt, the length x of a rectangle is decreasing, means minus 3 centimeters per minute, and the width y is increasing at the rate dy by dt. dy by dt is equal to 2 centimeters per minute. 2 centimeters per minute. When x is equal to 10 centimeters, when x is equal to 10 centimeters and y is equal to 6 meters, 6 centimeters, what is required to find is the perimeter and the area. The perimeter P is equal to 2 times x plus y, and the area of a rectangle is equal to x into y. Let us simplify this. Let us come to the perimeter. P is equal to, first let me take the perimeter. P is equal to 2 times x plus y. Differentiating with respect to t. dp by dt is equal to 2 into, this is dx by dt plus dy by dt. Substitute the values. dp by dt is equal to 2 into, what is dx by dt? Minus 3. Plus what is dy by dt? Plus 2. So this is equal to 2 into minus 1 is equal to minus 2. Therefore, the perimeter dp by dt is equal to 2. Negative sign indicates it is decreasing 2 centimeters per minute. dp by dt, the perimeter is the rate of change of perimeter. The rate of change of perimeter is 2 centimeters per minute, since negative sign indicates it is decreasing. Now let us come to the area of the rectangle. The area of the rectangle. What is the area? The area is equal to, area A is equal to x into y. Differentiate this with respect to t. What we will get? dA by dt is equal to, again, first function into differentiation of second function plus y into dx by dt. Substitute the values. dA by dt is equal to, you know what is the value of x? Here x is equal to, what is x? X is equal to 10 and y is equal to 6. X is equal to 10 and y is equal to 6. X is equal to 10 into dy by dt. What is dy by dt? 2 centimeters into 2 plus y is equal to 6 into dx by dt is minus 3. 10 2s are 20, minus 6 3s are 18. This is also equal to 2. So therefore, dA by dt, the rate of change of area is equal to 2 minutes. What is the unit given here? Centimeters square. 2 centimeters square per minute. 2 centimeters square per minute. This is the required area. Okay. Hope you followed. This problem is very, very important for 5 marks. There are 2 problems. At least you will get 1 question from this for 5 marks. So that's regarding the first 2 concepts. Let us discuss few more problems with a different concept in the next class. Let us discuss few more problems and few more concepts in the next class. Thank you very much.